All right, let's continue with numbers 4 through 6. Write an expression for the apparent nth term of the sequence. Assume n begins with 1. Now again, if we go back to the very beginning of sequences and series, we had absolutely no guidance at all on these. Now that we've studied arithmetic sequences and geometric sequences, numbers 4 and 5 can be done using those strategies. So it doesn't bother me which way you choose to do it. The big thing here is we're trying to figure out how, if I plug in 1, I can get 5. If I plug in 2, it gets 10. If I plug in 3, it gives me 15. If I plug in 4, it gives me 20. And if I plug in 5, it gives me 25. And again, some people are quick and pick it up very fast. Others are a little bit slower, and that's fine. But what you should see in each of these cases, if I take that top number and multiply it by 5, I get the bottom number. So our formula AN is that takes the n and just multiplies it by 5. So I'd suggest in those questions to write out 1, 2, 3, 4, and 5. Put those first 5 terms underneath it. And then trying to find some way of getting there. This one's, again, a little bit tougher. It's easier if you happen to notice this is arithmetic, where the common difference is -2, or -2, and then go it that way. But we'll pretend that we didn't see that and still look at how we can figure out what that nth term is. So we're looking at what I do with 1 to get 50, what I do with 2 to get 48, what I do with 3 to get 46, what I do with 4 to get 45 or 44, and what I do with 5 to get, that's not 45, that should be 42. Okay. So it's something to do with that 50. I mean, it's, 50 take away 2 is 48, but 50 take away 3 is not 46. Neither is take away 4, give me 44. The difference of 2 is going to come into play here. So what you should see at some point is I'm going to have to double each of these numbers. I'm going to do that right here. So if I double, I get 2, double, I get 4, double, I get 6, double, I get 8, and double, I get 10. And maybe you can see at that point, if you subtract those orange numbers from 52, that will give you the number underneath. So 52 take away 2 gives me 50. 52 take away 4 gives me 48. 52 take away 6 gives me 46. So AN is going to be 52 take away 2N. Now, real quick, I'm going to jump ahead to the whole idea of arithmetic sequences. If you recognize that that was arithmetic. And so let me do it up here, arithmetic. All you need is what is our common difference, in that case there, take any term, subtract the term before it, and we get -2. And then we need our 0th term, which is the term before the first term. So just kind of read the pattern right to left and figure out what would come next. That would be 52. So our 0th term is 52. And then our formula is dn plus a0. So d is -2, n plus a0, which is 52. Okay, and you can see it's the same thing as what we have there. So I do think number 5 is a little bit easier to do if you notice it's arithmetic. It can be pretty challenging completely just on your own without any sort of direction. And then number 6, I would first of all take that first number 2 and put it over 1 just so it looks the same. And what we should note is AN is going to be, you got a numerator of 2. So the question is, what can I do to 1, 2, 3, 4, and 5 to get those denominators of 1, 3, 5, 7, and 9? And so what I hope to see is that if you double them, So double 5 gives me 10, then take 1 away. Double 4 gives me 8, take 1 away. Double 3 gives me 6, take 1 away. And so we get 2n minus 1 in the denominator. Right. We'll take a look at number 7, then we'll break. All right, so write the first 5 terms. So the first term is going to be 49. That's what we are told right here. Then we're told in this next phrase, take any term, including the first one, 49. And if you add 6 to that, you get the next term. So that's what this statement says here in English. So if I want the second term, do the first term plus 6. If I want the 10th term, it's going to be the 9th term plus 6. So we have the first term. So all I need to do is just add 6, 55, is the next term. And then I add 6 more again, takes me to 61, which gives me the next term. Add 6 more, I get 67. 6 more gives me 73. And those are the first 5 terms of the sequence. All right, we'll pick up on numbers 8 through 9 in the next video.